We are going to discuss the sources of error. And then to eliminate the error, we need to calibrate the level. We need to check for the errors, and then we will do the adjustments if the error exists before doing the labeling. Sources of error in labeling will include the personal errors, natural errors, and instrumental errors. So mainly the errors come from three sources of error. Personal errors. Personal errors may occur in any stage of the labeling process. With the instrument, the errors may be incorrect setup, so where the bubble not center, so then the label will not be perfectly horizontal. Stability of setup, so you don't have the stable ground. Bumping the tripod during observation, focusing the crosshairs and the staff, the parallax error due to the errors of the telescope. While you are holding and taking the readings, so there may be the errors from staff not vertical. So you hold the staff over here and it should be vertical. Extending the staff incorrectly. So we will have several segments of the staff over here. So we need to fully extend the staff to get the right reading. Unsuitable change points. Holding the staff on different places at a change point. At a change point, but if you take the wrong point of the change point, you hold the staff incorrectly at that point, it results in the error. Incorrect booking or staff readings. So the wrong reading or writing of the results over here is a common error. So you should take the reading at the center of the telescope. The center crosshair here will be the elevation of the point. It's not the stadia hair, so you need to take the reading at the center crosshair. The natural errors may be due to the wind. It will cause vibration of the instrument and staff. It may be due to the sun and temperature. It may be due to the curvature of the earth, and may be due to the refraction as well. Instrumental errors. The errors may come from the instrument, include instrument not in adjustment. We're going to use a two-peg test to eliminate the error. We can see later on. Parallax, that is the error of the telescope. We can use the focus knob over here to adjust the parallax error. Crosshairs not exactly horizontal, automatic compensator sticking. Other errors from the instrument, we can do the calibration using different staffs. If you change the staff during labeling, different staffs may have different errors in the graduation. So then results in the errors of the readings. Staff zero error. If a staff is worn at the base, so there's going to be error in the reading. Conditions of survey mark. We will use the benchmark to start the labeling. And sometimes if the survey mark is not accurate, it will result in the errors. Now, let's look at a very basic test to eliminate the error if it exists in the instrument. So it is a two-peg test. We are going to check if the line of collimation is horizontal or not. So that is the purpose of the two-peg test. This test involves setting up the level between two pegs, and that's why it's named two-peg test. Step number 1, we will set up the instrument in between two pegs A and B. So the distance D1 equals distance D2. So the instrument is in the middle of point A and point B. We take the reading at point A and then turn the telescope to take another reading at point B. So then the height difference between point A and point B equals the reading at point A, HA1 minus HB1. It means step number 1. In this step, if there are errors in the readings, so they will be cancelled, because the same error will occur because you have the same distance from the instrument over here to point A and point B. So assume that, for example, if the line of collimation is not horizontal, it has an angle with the horizontal line. If you have higher error, so when you turn the telescope to each point, you will have the same angle with the horizontal line. In that case, if the reading is not HA1, it's HA1 plus or HB1 comma, sorry, not plus. In this case, the height difference is still the same as HA1 minus HB1. So that's why you are going to get the true height difference between point A and point B. So in this case, any errors will be cancelled out. So then we move on to step number 2, where we move the instrument to a point near point A. And then we take the readings again at point A. So you have HA2, and then you sight to point B and take another reading, HB2. So if there's no error of the instrument, so then you have another readings over here. So you calculate the height difference of point A and point B again. The height difference equals HA2 minus HB2. Because point A and point B are fixed, there should be the same height difference between point A and point B, despite you move the instrument from the between over here to out of point A. So then to check for the errors, we just compare your height difference calculation from step 1 with step number 2. If there's no error, so there will be the same height difference, and then this value should be 0. HA2 minus HB2 compared to HA1 minus HB1. If error exists, it means the line of sight here is not horizontal. So then in step number 2, so you will identify that the height difference of point A and point B will not equal the height difference you measure in step number 1. So then there will be the differences from 2 steps, and then you can identify that error. And in that case, it's not a 0 value. So that is the idea of how we do a two-peg test. The two-peg test is illustrated in the previous slide with a diagram. So this is the summary of the procedure. So normally we will choose the point A and point B with a distance of 50 to 60 meters. In step number 1, we calculate the height difference, and it's going to be the true height difference of point A and point B. In step number 2, we move the instruments to close to point A or point B, and then we measure again the height difference between point A and point B. So we need to keep the same order of the readings. You take the reading to point A and then point B in step number 1. Then you have to do the same order. You take the readings from point A first and then point B. Then you will have the correct calculation. So we compare step number 1 and step number 2. If there's no error, we should have the same height difference. So then the results of this equation should be 0. If error exists, so we need to compare to the allowable error or the limit. So normally we allow for 1 millimeter of the error over 10 meters distance between A and B. So in this case, if you have AB equals 60 meters, so then the allowable error will be 6 millimeters maximum. And then if the error exists more than the allowable error over here, we need to adjust the instrument. Otherwise, the error will occur in every readings later on. And then you will have the very high error in the leveling, and it's not acceptable. To adjust the instrument, you will need to make sure that you have the correct reading at point B, and we can calculate the value at point B, and we will adjust the instrument until you get the correct reading at point B, just following the formula over here. So you are not doing these steps. If there is the error, we are not calibrating, we are not adjusting the instrument. We need to bring it to the supplier, so they are going to do that for us. But we need to know what is the correct reading it should be. We need to know how to calculate this value. But we are not doing the calibration. We need to bring it to the workshop to make sure that they can do it properly. So now let's look at the example of the two-peg test. So in this case, we have point A and point B 60 meters apart. Step number 1, instrument in between point A and point B. Reading at point A 1.513, reading at point B 1.613. So the true height difference between point A and point B is 1.513 minus 1.613. So then you have the full 0.1 meter. So point A to point B, you're going down 0.1 meter. So this is the height difference between point A and point B. Point 0.1 meters going down, so then it is indicated by minus. Step number 2. So then we just move the instrument to close to point A and you take the readings again. The same order, point A first. 1.554. As you move the instrument to another position, the reading is going to be different. Point A first and then point B. And calculate again the height difference. 1.554 minus 1.666. So then you can see that you have the height difference is minus 0.112. So indicate a fall from A to B. So here we see that there is the error. So there should be the same results. If there's no error, then the height difference between A and B should be the same, despite you move the level. But they are not the same, so we have to check the error and compare with the limit. So now you just take the height difference in step 1 minus the height difference in step 2. Step 1, step 2, minus together, so then you get the difference in the results of 12 millimeters. So we know that the allowable error is 1 mil per 10 meters or 6 mil per 60 meters in this case. So the error is too high, larger than the limit, so you have to adjust the level, and you can't use that for your next job. If the level has no error, so then you should have another reading at point B. You should have another reading at point B. If the level is adjusted, that value should be 1.654. So use the formula in the previous slide. Because you will have the same results in step 1 and step 2. So the height difference over here should be the same as in step number 1. So it should be minus 0.100 as well. So in that case, you can find the correct reading at point B. And then you can adjust the instrument until you can see these figures in the telescope. So that's the way we do the two-peg test for the level calibration. Lastly, we're going to look at the parallax. That is another error of the instrument. Parallax is the movement of the crosshairs across the image when the eye is moved left and right or up and down. It is an object focusing error. So in this case, you can't take the reading consistently, because when you move your eyes up and down, so you're going to see that the crosshair in this case is moving as well. So for example, if you think that the level and the reading should be here, but when you move your eyes up and down, so you see that now compared to the previous position, the elevation is changed. So in this case, you can't take the same reading if you move your eyes up and down. So that is the error. So we need to make sure that we have a stable crosshair despite we're moving your eyes up and down or left or and right. So then we need to know how to eliminate the parallax, because you need to check this and do this in your practical. So when you identify the parallax exists in the telescope, so then you need to do step number 1, turn the object focus knob to infinity. So then we will need to change the focus. We turn the eyepiece focus screw until the crosshair are fine and dark. And then we refocus the object focus until we can see the stuff clearly. And then we try to shake your head slightly, move your eyes up and down a little bit, and now if the crosshairs remain steady, they are in focus and there's no parallax error. If not, we need to repeat this process. Turn the object focus knob again to infinity, and then adjust again the crosshair using the eyepiece focus screw until you can see it fine and dark. And then you change again the object focus onto the staff until you can see the staff clearly. So then you try to move your eyes up and down a little bit to make sure that you have the same reading on the staff.